Hello there. In this video I'm going to talk about combination of capacitance, and thereafter I'm going to look at the calculation of capacitors in series and in parallel combination. So to start with, let's first discuss about parallel combination. So parallel combination of capacitors are capacitors which are connected in parallel, like these ones in this diagram here, and these two plates are connected to the positive terminal, and these other two plates are connected to the negative terminal. So the voltage across the battery here is equals to the voltage in C2, which is capacitor 2, and in capacitor 1, that is V is equals to V1 and is equals to V2. So voltage is equal in capacitance. So how can we find the equivalent capacitor, which is the total capacitor across these two capacitors? So to find the equivalent capacitor, what we are going to do is that since voltage is equal across these two capacitors here, then what you should know again is that charge is not equal. The charges which are passing here are not equal to the charge there. So to find the total charge, what you do is you simply say total charge is equals to Q1 plus Q2, where Q1 is the charge for capacitor 1 and Q2 is the charge for capacitor 2. So we know that charge is equals to C multiplied by V, where C is the capacitance and V is the voltage. So we're going to replace where there is Q, we put CV. So where there is Q here, we are going to put replace with CV, so that we come up with the formula to calculate the equivalent capacitor, the total capacitor in the capacitors. Okay, so to do that, we are going to say our total capacitor, which is equivalent capacitor multiplied by V, is equals to CV plus, which is C1V plus C2V. C2V. Since V is constant across these capacitors, we said our V is equal, so it is constant. So we are going to have our equivalent capacitor is equals to C1 plus C2. So to find the total capacitor of capacitors in parallel, like these ones, you simply add the capacitors. If this one is 2, then 2 farads, then and the other one is 3 farads, then the total capacitor, which is the equivalent capacitor, is 2 plus 3, then it will be 5 farads. So that's how you calculate the equivalent capacitor in parallel. So in series it's a different story, where the capacitors are connected in the same line, or in the same queue, or in the same wire. Then the charge which is passing through this capacitor here is equal to the charge which is passing in that capacitor there, but the voltage is V1 is not equal to the voltage V2 across that. So to find the total voltage passing through these two capacitors, you simply say our total voltage is equals to V1 plus V2 there. So to find the equivalence capacitors, which is the total capacitor, what you do here, you simply replace where there is V, you replace what is V. V is equals to charge over capacitance. So you replace where there is V there, you replace and make C the subject of the formula. So to do that, we are going to say our V, which is our V total, the total voltage is V1 plus V2. So since V is equals to charge over capacitance, which is equivalent capacitance, this side is equals to charge over C1 plus charge over C2. So we know that charge across this capacitor is equals to the charge which is charges which are at that capacitor there. So charge is constant. So since charge is constant, we are going to have 1 over our equivalent capacitor, which is the total capacitance, is equals to, since charge here is equal, charge here is a constant, so we're going to have the 1 over C1 plus 1 over C2. So to find the total capacitor, which is the equivalence capacitor, you simply find the reciprocal of capacitor 1 plus you add it to the reciprocal of capacitor 2. So let's see how you can do that in a problem. So I have a problem here which is saying find the equivalent capacitance of the capacitor in this figure here. So to find the equivalent, which is the total capacitor, what you should do, you simply simplify the diagram to come up with the total capacitor. Here we have this one, which is in series to this one here, but these two are in parallel to each other. That one and this one are in parallel. So what you do, you first find the total of this one, so that you only have the ones in series if you add those plus these. So you are going to have something like this. You are going to have something like this, and a battery here. Okay, so when you add those two which are in parallel, so to add these two which are in parallel here, 6 plus 2, you are going to have 8 here. Here it will be 8, and this one is 8, and this one is 8 microfarad. So in this case now, we have all the 3 capacitors in series, so it is easy for us to calculate. So to calculate the equivalent capacitor for capacitors in series, we know that we simply get the reciprocal of these capacitors. So let's say this is Q1 and this is Q2 and Q3. Since there were 2 there are 2 here. So this one will be will be C2 and C3, and this one here is C1. This is C2 and C3, and this one is C4. So we are going to use the same formula we developed here, this formula here, to find the equivalent capacitor, which is 1 over equivalent capacitor is equals to 1 over capacitor 1 plus 1 over capacitor 2 and 3. Since they were in parallel, we have added them, so it is C2 and 3, and we have 1 over C4. So our equivalent capacitor will be equals to 1 over 8, which is C1, plus 1 over 8 plus 1 over 8. Since the denominator is simply the same, you just add the numerator and over 8. So we are going to have 1 plus 1 plus 1 plus 1, which is equals to 3 over 8. 3 over 8 there. So this one is saying 1 over the equivalent capacitor. So to find the equivalent capacitor, get the reciprocal of this, which is 8 over 3. Or you cross multiply there and divide by that 3, you are going to still get the same, which is 8 over 3. Dividing this, you are going to have this as your equivalent capacitor. So that is the solution on how to find the equivalent capacitor of this question, which is here, this question here. So that was A. So let's find B. That was A, find the equivalent capacitor. Now B is saying find the charge on the capacitor. So to find the charge on each of these capacitors. Find the charge here, find the charge there, and find the charge here. So to find the charge for capacitors in series, what you do, since charge, charge is equals to CV. So this capacitor here, it is the equivalent capacitor. You replace in the formula where C is the equivalent capacitor for the capacitors in series. For capacitors in series, you use the equivalent capacitor. And the voltage, we already have it. The voltage is here, which is 9 volts. So we are going to say for Q1, we are going to use the equivalent capacitor multiplied by voltage. So the equivalent capacitor, we already found it here. It is 2.67 microfarads. So we are going to replace it here, multiply it to the voltage, which is 9, and then we are going to get 24 microfarads. So this is the capacitor. So this is the charge for Q1, which is C1. So for this one here, it is 24 microcoulombs. So to find the charge for this one here and this one, we are not going to use the same formula, but instead we are going to use this formula here, Q2. For Q2 and Q3, we are going to use this one. So this formula, you get the total charge and multiply it with C2, the one you are looking for. We are looking for Q2, so we are going to use C2 and C2 plus these 3 here. That is, for this one here, what you do, you get this one. If you're looking for the charge for this one, then you say 2 over 6 plus 2, this one, and then you multiply it to the total charge of which is flowing through this circuit. So the total charge which is flowing here is the same as the charge which is flowing on those there, which is equal to the charge which is flowing there. We said the charge for capacitors in series is equal, so the total charge will be just 24. Will be this 24 here. This 24 here will be the total charge. So to do that, we are going to say our Q2, since it is in parallel, we are going to say that C2, we add the 2, we multiply it to the total charge, which is 24. So we are going to find that our charge will be 2 plus that 6 there will be 8 plus 2 divided by this 8 multiplied by 24. These units there, they will cancel. We're going to remain with these microcoulombs. And then here 8 is 3. 8 into 8 is 1. So 3 times that 2 to be 6. So this will be 6 microcoulomb for this one here, these 2 here. For 6, we do the same, that is Q3. We do the same, but here we are going to say C3. 6 is C3, capacitor number 3. And we get the total charge, multiply it to C3 over C3 plus C2. Our C3 is 6. Is 6 here. 6 divided by the total of the two capacitors, which is 8. So we do the same. 8 here, it is 3. 8 there, it is 1. And 3 times this 6 here to be 18. So our charge on that 6 microfarads, it will be 18 microcoulombs. So the charge which is flowing here is equal to the charge which is flowing here. That is, here we found that it is 24, so even here it is 24. And if you combine the two, then it will be also 24. That is, if you add the charge for Q3 and Q2, should give you 18. This Q2 here, it should be 18. So let's see, we have 6 for Q2, so 6 plus 18. 6 plus 18, with this 18 here, it is 24, meaning the total charge is correct, it is 24. So that's how to calculate the capacitors and the charge of a capacitor. Remember, don't forget to like, subscribe, and leave your comment in the comment section below concerning this video.